That way there aren't like tests and test scores shown all over the place, but when I keep them hidden, sometimes I keep them hidden from myself.
Oh, I graded the wrong one.
So my people who are absent on Friday, let me get you to the work day, and then I'll go find your test and where it. Oh, I think they're right here. So you guys can grab correction papers. The nice thing is, here we go. The nice thing is these corrections are half points back, quick reminders for everybody, and they're due this Thursday, right? So it could be homework tomorrow after the test, etc., or on Wednesday. We need to go over 6.5 questions and try to alleviate the fears of those of you that tried to do the entire homework when you did not have to do the entire homework. It was in a Google Classroom. Bring it back. Because there is one type of problem that will not be on the test that you don't have to worry about. And if it is on the test, I'll have you cross it out the day of.
Is it the
Dim Wobbers. Yeah, Dim Wobbers. So let's talk about 6.5. Let's get through that quick, and then let me go ahead and grab out an old version of the test, and we can talk about specific hints and tricks and ideas about what you need to have memorized, don't need to have memorized, etc. And then, I do have 6.5 theoretically open, but now my book is completely not working. And then you guys should be able to just have a, nothing's working. Hi, PDF that I paid a lot of money for, and now you're not happy. Okay. That's all right. I have it ready if we need it, aka my webcam, because I guess the book isn't working. But let me give you guys another 30 seconds to go ahead and grade number 28 and get out of the webcam. There you go. Now, be looking at the odds and see if you have any questions. And open up your notes or your test review or wherever you like to write down hints for tests. Because I am just about to give you those. What kind of?
Are we supposed to grade this in degrees or radians?
Oh, the entire chapter 6.1 to 6.4 was degrees. This section was probably radians.
That's why I did it wrong.
Which means you might have an accurate answer as far as plugging in. It's just not matching up with 5.26, right? So we could always take that too many people borrowed my calculators today. 5.26. Most of you were in degree mode because I told you the whole chapter was degree mode. But this last section, 0.5, was not physics. It was coming back to complex numbers, which is back kind of more in the math realm. And basically, for future maths, we pretty much stay in radians because they're more natural, which is kind of weird and awkward because degrees are more natural to your head, but not more naturally occurring. We could convert 5.26 by multiplying by 180 over pi, right? To see what it would be. And it would have been 301.376 degrees. Does that sound right? 301.376 degrees. And if you didn't get that, it's because when you did your tangent inverse, you didn't think of your picture and where your picture actually was. Because if you had looked at the original number 28, guys, what quadrant is this complex number in? If it's a positive x and a negative y, if it's a positive real number and a negative imaginary number, yeah, it would have been over here-ish and it would have been down here-ish. Ooh. How could you have gotten here? Now, some of you might have done the tan inverse, which would have been the negative angle, but to be honest, for complex numbers, they always go a positive route. I'm just trying to warn you, if this was a multiple choice answer, so that you can make it match. You guys might have done second tan inverse in degree mode, and gotten the negative angle because it's a lot shorter, it's a lot smaller, and it's what your calculator would give you. That -7 divided by 3, parentheses, 3 rad 2. Is that in degrees? Oh, tan inverse. -58. Is that looking better? 0.78.
Yeah.
But the dilemma is, could you have figured out that -58.78 is the exact same thing, adding 360 as that 301.376? 0.220, and that would be the exact same thing as the radian times pi over 180 of 5.257. And if you had done tangent inverse the other way in, let's see, what would that be, in radian mode, you would have actually had to have done something kind of equally as confusing, if not more confusing. Because the other way, if you had been in radian mode instead of in degree mode, the problem is you would have gotten a negative number and not really known what it meant. Negative 58, I know it's fourth quadrant. Okay, I could get there by going the other direction, by adding 360. But in radians, would you have known that negative 1.025 wasn't good enough? 1.026, and that you would have needed to have added 2 pi? So it's a little bit rough in the sense of in this section 6.25, or sorry, 6.5. I did take away that last de Moivre's theorem and raising these complex numbers like to squares or to the fractional power, like 1/3, like a cubed root. I did take that away. But what's still in there is, number one, they like radians for complex numbers because it's more back into the math, away from the physics. And number two, maybe something that we should add into our notes for that. Ooh, that's not you guys. That for these complex numbers, for these z equal a plus b i's, which remember can also be r cosine thetas plus I sine thetas, they always want theta to be within 0 to 2 pi. So this little guy, the negative 1.02, it wasn't in the right range. I guess that shouldn't be an open because 0 is 2 pi, so it's going to go up to 2 pi, but not including. So they want a theta that's turning in the standard positive way and not the negative way. Oof, we still had something kind of complicated, huh? All right, even though my 6.5 is not open, yep, not even close. Let me get your actual notes opening. That way if something comes up that would be better answered if I did turn to your notes. And then let's go to the webcam and see if we can open up. If you guys have something in 6.5, were there any other problems? You guys should have seen, I think, the radians, not degrees, in the answers to the other questions though, right? Oh, okay. Any other odds we need to look at? Because that was the only even in the problems that you guys needed to do. Oh. Well, because complex numbers are numbers too. So the same way the absolute value can be helpful for normal numbers, like when square rooting is squared, they're saying, okay, well, what does that mean for complex numbers? And so you're thinking of an absolute value. Oh, because the answer key was doing it a non-pictorial way. I was doing it the way where it's like, oh, hey guys, look, it's a negative rotation. Remember, tangent inverse only goes down 90, up 90, down pi over 2, up pi over 2. The calculator spit out this in degrees, spit out this in radians, and so I said, oh, no big deal, just add 2 pi. But what the answer key is doing is trying to give you like a formulaic way that you don't need the picture for. And so they're saying, whenever you use arctangent, it's either going to give you a first quadrant angle or a negative first quadrant angle. And you can always do, why would you always do 2 pi minus though? If it's in the first quadrant, you don't want to do 2 pi minus. They still would have had to have considered it was in the fourth quadrant. It's the exact same math because they're putting a minus in front of the absolute value. I'm just saying it is a negative, so just add 2 pi. So ironically, it's the same math. They're just saying, like, it is a negative, just make it a positive and subtract it from 2 pi to get that fourth quadrant angle. I'm saying start in the fourth quadrant with the negative angle and add 2 pi. So it's just two different ways of doing it, I think. They're saying take your 2 pi and take away, and I'm saying take where you are and then add the 2 pi, and they both end up in the same spot. Does that kind of make sense?
Yeah.
Okay. I'm not sure why specifically they like that way better. But sorry, back to the homework and back to the odds. Anything else you guys want to see? Yeah, Sophia. 31? 41. This is the one where they give it to you in the trig form. And they say that you're allowed to use your graphing utility. Remember, you're allowed to use your calculator in this entire chapter, which is really nice. But to write the complex number in standard form, this is another clue that you guys would have needed to have switched to radian mode. Because those aren't degrees, right? Pi over 9. But this one is as easy as, wait a minute, we have it in the trig form. We want it in the standard form. And the standard form says just who is A and who is B.
I was confused on how to put into the graphing utility.
Yeah, I got you. All you gotta do is have a computer that works. Number one.
We don't have that.
Yeah, never. Okay, and then just do 5 cosine of, ooh, hold on, we've been in degrees all chapter, so make sure you're in radian. But 5 cosine of, and then just throw in your, let's jump to the end because we can do that shortcut. Pi, second forward goes to the end, second back goes to the beginning. Pi over 9. 4.698 would be your real component. There we go. So I can change 5 times cosine of pi over 9 to be 4. Come on, computer. 4.698. Because I'm just taking that 5 and I'm distributing and I'm multiplying it, and then I'm taking out, careful, this I, remember, he just stays because he's that imaginary. But then all I have to do is go ahead and copy and paste this dude and change him to sign. Does that make sense? There he is. To get that 1.7 or 7. These are actually the nicest ones, even though they can be the most confusing ones. I don't know, it's coming. There we go. Just say it's done. But yeah, that was just a plug and chug to your calculator. The harder one is going the other direction, because the other direction you have the A and B, and you have to plug into those formulas basically from vectors where you can say R is equal to A squared plus B squared, and theta is equal to tangent inverse of B over A. But in my notes, I'm very particular not to say equals because of that whole weirdness that just happened in the answer key on number 28, because the quadrant I was in was very different than the inverse. Well, it wasn't very different. They gave me the right angle from tangent inverse, but the wrong way. So then, in that case, I say, in something like this, just to use tangent inverse, and then check out the picture to figure out what angle they want. Yeah, but that's the hard one. They have to plug in the formulas from vectors. This guy is just a simple, like, plug and chug. Get me a decimal. Get me a decimal. Anything else from homework, guys? I know it could have been messy. We're sure. All right. To that end, let's go ahead and try to narrow down our topics. Let me get out of this webcam because I think he's slowing everything down and making everybody mad, or everything mad. I think I do have your test review written down here somewhere. There you go. Let's peek at really quickly if there are any of these you guys are allowed to ignore because of the formulas I took away. So I'm just looking at 105. That's work. That one's okay. 97, 99. Those are all vectors. Okay. Yeah. Okay. In this review, kiddos, I didn't give you any problems from section 6.5 just because we literally just did that homework. So I'm not saying that it wouldn't be a good idea to peek at 6.5. I just want you guys to realize that as you're doing the test review, I haven't required any practice problems from that very final section that we went over. So check it. 105 is your last one. And that's that work one. There are lots of like imaginary complex numbers I could have given you. I just chose to make your review a little bit shorter, stopping at vectors, because you guys just practiced that. Does that make sense? Okay. So it's not saying that none of them are on the test, because we're going to talk about the topics on the test right now, but I just chose to stop the practice problems at vectors. Go ahead, June. What's up?
So you know there's a lot of formulas for like 6.
You might want to wait until I talk about the test.
Okay.
So honors pre-calc, chapter 6, 6.1 to 6.5, but cutting after Moivre's theorem. You are allowed to use your calculator on the entire test. So first, mental note to yourself: make sure you have a calculator. Okay. Formulas you need to have memorized. Okay. 6.1 and 6.2. Formulas you need to have memorized. 6.1 and 6.2. What are those? Law of sines.
Oh no.
Law of cosines. Oh, law of sines is a nice easy one. Sine A over A, sine B over B, sine C over C, or flip them. Law of sines and his area formula, which is A equals 1/2 BC sine of A. Law of sines and his area formula, and law of cosines and his area formula. 4 categories. Law of sines, his area. Law of cosines and his area, which is Heron's formula. The S times S minus A, S minus B, S minus C squared root. Law of cosines, you get to choose how much you want to memorize. Just make sure you have at least one law of cosines that you can work off of. I think I might advise you to do one of each. I'll write those on the board before we're done today if you just want to be able to take a picture to study them. So law of sines, law of cosines, and the 2 area formulas. The problems that involve those are pretty straightforward, meaning law of sines, law of cosines, I don't really give you pictures. I let you draw your own triangle. But if there is like a tree in the ground or something like that, I do give you a picture for that, which helps a little bit. And I do try to make sure that I say, like, determine or find the area. If you see area on the test, double underline it and be like, okay, it's one of the area formulas from 6.1 or 6.2. So the first 1, 2, 3, 4, 5, 6 questions on the multiple choice are 6.1, 6.2. And then it shifts to 6.3 vectors. Okay? Vectors. What if I give you components? The side brackets, right? The ABs. Do you know how to add, subtract, multiply, dot product, unit vector? If I give you components, do you know how to add or subtract, multiply, aka dot product, or find a unit vector? If I give you an initial and terminal point, do you know how to find components? Or if I give you magnitudes and directions, despicable me, do you know how to plug into formulas to find components? If I give you I's and J's, do you know how to go to components? Do you know how to plot a complex number? Ooh, that's 6.5. How to graph it and find the absolute value of it. There's a formula for that, yeah. For complex numbers, do you know how to graph it and find the absolute value of it? Ooh, Sophia, that question you asked in homework? It's a good one for the test. Except the one on the test is degrees. You don't even have to go to radians. Do you remember what problem that was, Sophia? Was that 41? You might want to peek at 41 and 6.5 and make sure you know how to use your calculator. Do you know how to multiply 2 complex numbers? Oh, I'll take that one off. Can give you a de Moivre's one. Just kidding. So everyone will just get that one right and they'll have you cross
Say
that.
no to the multiplying.
Yeah, just multiplying, yes, but de Moivre's, we'll just cross that one out and everybody gets it right. Yes, you didn't have to know how to multiply, but the power one, the de Moivre's one, you won't have to. I'll just cross it out. Okay, word problems.
We're there already?
Yep. Word problems. I see.
Oh, Misty, how many vector problems are we gonna have?
1, 2, 3, 4, 5, 6, 7. 7 multiple choice.
Are you giving us any formulas or do you just memorize?
Hold on. All I've said so far, the only formulas you need to have memorized are 6.1 and 6.2, law of cosines and its area, law of sines and its area. Okay, word problems. I see something to do with work, but
Oh, so funny.
but only if it's
laughed
over a
so
certain
hard.
distance. I wonder if I could make a funny joke out of that, but I'm not going to. Work, but work across the horizontal axis. Like sliding the stool on the ground, or sliding a table on the ground, or sliding a something on the ground.
So it's not, we're not gonna have like.
It's not the weird angle. Yeah, not the weird angle one. I mean, it is at an angle, but an angle with a horizontal, not an angle with an equal.
So it's gonna be like going to like the little boat problem.
It's-
Which it's here.
Not the work.
Oh, okay.
It's here. No.
Yeah, but
It's not vibing.
it's moving here and you're pulling here.
Kayla's. But it was.
Oh.
Is this one harder? Or
It's like the homework one, and it's like the example in the notes. That's all I. Okay. Wait, that was one word problem. There's another required word problem, and there's another bonus word problem. I'm not going to tell you which is which. But in the vector section, do you guys remember that there were 3 vector problems, word problems in the vector section? Okay? The work one was the dot product section. It was actually 6.4. So in the vector section, 6.3, there was something at an incline, and there was a very special little triangle that would make your life so much easier if you could fill it in. You might want to look at that. There's something on an incline. There's a very, not the work, but there's a very special triangle to figure out like the force of gravity or the weight or the force that's being required to keep it from slipping. Very special little triangle.
Oh, with the baby.
There was also one that had to do with multiple vectors working all at once on something, like the wind and the plane and the this and the that, and how to get it into components and put it all together. So we had the incline, the special triangle. We had lots of things acting at once with magnitudes and directions. Let's just get them all into components and add them all up. And then we had the one where you had multiple objects acting at once on something, whether it was like 2 cables on like a hook, or whether it was 2 cranes on a load. That was like the tension one. So we have the tension one, we have the incline, and we have the lots of vectors acting at once. One of them is a bonus, one of them is a multiple choice, and one of them is not on the test. But you don't need to worry about any other types of word problems. Okay. The most pressing question from Jaden, and then from Emily, and possibly in others of your minds. So how am I saying you only have to have memorized law of cosines and area and law of sines and area when there are all these formulas for vectors in 6.3 and 6.4 and 6.5?
They're giving it to us.
They're pretty big.
Nope, but you're allowed to make a 3x5 card and put anything to do with vectors minus example problems to prepare for tomorrow and have with you on the test tomorrow.
But nothing with law of science.
Nothing with section 6.1 or 6.2, but you can write diagrams, you can show pictures, you can write formulas, you can show components. You just can't write example problems, but you can do pictures for example problems, like an incline with a special triangle on it would be a great idea.
So it could be like an example.
That's not solved out.
Okay.
Yeah. You can do diagrams for example problems, you just can't do the actual example problems. I'm going to go ahead and get out 3x5 cards. If you guys want to borrow and start playing with it right now,
I
or
would love
starting
one.
things. But borrow, go ahead. What's that?
That was in the book. Could you draw that exactly?
The exact diagram, just don't solve, like put the numbers,
You can't put numbers.
equations. Right.
draw a picture.
Yeah, you can do like an A and a B and a,
Okay.
you know what I mean?
Yeah.
Here are 3x5 cards if you guys want it. There you go. And Laurel, I don't remember what's in the folder now. But I know the picture that I drew in notes would be a great one to draw, especially with the ink line.
Right there.
So what's allowed on the card?
6.3.
6'3"?
I don't, but I will
6'4".
be a good friend.
6'5". Yeah? Yeah. So no law of signs, no law of cosines, no area. Everything else is fair game. Just no examples with numbers solved all the way through. Yeah?
Yeah.
Okay. Now, every year I have to take someone's formula card and I get my scissors and I start cutting out and throwing away pieces. Don't make me do that to yours, okay? Please, I hate it. And it's so sad because whenever I start cutting, I'm cutting out stuff from the other side because people usually write on both. Just no law of signs, no law of cosines, no area. Are we good?
Yes.
Okay. Any other questions on details?
I'm going to do my homework.
Did I say anything that you're like, oh, stink, can you do an example of that? No? All right, you guys have the review up here, you have the problems up here, you have books up here. I have my notes if you guys want me to turn to a certain page because you want to start making things on your formula cards, I can do that too. Or if you just want to work, that's okay also.
No, I'm doing the coronavirus is in OC.
Oh, Joe Cow was telling me that.
Of course, Jim.
He said that people were in quarantine and being tested.
It's literally just World War
I was reading some article that said it doesn't pose as much threat to America as it seems.
the bubonic plague.
Oh, thank goodness it's not that bad. Not that it's not dangerous.
Coronavirus is not. That's why she thought I was crying.
He thought you had the coronavirus?
I was snowboarding, and then
Okay. A lot of people can't focus when people are talking about random topics, so we're just going to go ahead and help everyone have a productive 10 minutes by focusing in. Sound good? Okay. If you guys need me, let me know. Yeah. This one, right? Yeah, that's a good crayon.
My patience is over.
I have a few questions. Do we need to know direction?
I said. To answer your question, I want to address the whole class, KJ. The word problems I was already very specific on, so I'm going back to multiple choice really quickly. Now that I've told you you can make a formula card on 6'3", 6'4", 6'5", are there some formulas in 6'4" with dot products and angles between, or projections that you might want to put on the card just in case? Yes. Okay, so remember there were applications of dot products. Just throw those formulas on the card just in case. There might be a random problem in multiple choice from one of those applications of a dot product. I'm giving my KJ in case I didn't answer.
what's a parallelogram?
Parallelogram is like a rectangle that's been side wackered a little bit, like it's going. Parallelogram is a quadrilateral, 4 sides, where each side is parallel,
Oh, okay.
but it's not guaranteed to have right angles. Okay, did that answer? Angle between, there are some formulas in section 6.4 that you should probably throw down. If you're asking for whether or not you need to find angles in general, that's 6.3, going from components to direction magnitude or direction magnitude to components, and I think I said both of those as I was going over this.
And this one right here, the complex, the plot, the complex number. Is this like one problem with the graph and find absolute value? Is that just separate?
I believe so. I believe that's one problem.
And 41, you
we're going from trig form to standard form of a complex sentence. Does that make sense?
And we may know that word.
So at the end, should you look at 41? Should he look at 41?
Spelled like I'm not just. No, I appreciate it.
And you'll type it out for them. Bianca's going to bed. Claire's going to bed.
Rocky was here though. I think she
I don't know how far it's not. Sorry. You need to walk on the freeway.
Yeah, you're right.
Yeah. Oh.
Then you could even use the class period to.
See, I don't get it. If they're parallel, how can they be different lengths?
It wouldn't be possible for these to be different lengths, but it is possible for these to be different. That could be 10, this could be 16. And that'd be 10, that'd be 16.
Oh, okay.
You see it? So they're not telling you that across from each other are different, they're telling you the side by side are different.
Okay.
Is that cool?
Yeah.
If you guys do take your formula or make your formula card today and you want to come show it to me and see if I see anything that you might want to add in or clarify, feel free to ask. For the work problem, I said it would be one of the nice ones that's just on the horizontal. So it won't be one of the complicated projections, but I did say that there is going to be like a random multiple choice that uses an application from 6-4, so it could be the angle between formula, or it could be like just a projection, not the work. Does that make sense, Caitlin? So you want to write down the formula, but the work problem isn't that hard. I did tell you guys I was going to write down the law of cosines, law of sines formula, so you could just take a picture and study it. So I'll do that over here on the side. Because these are the ones that aren't allowed to be on your card.
Just that.
Let's do a square.
I know, just don't come after me, please. Just don't aim for me.
Guys, these are those 6.1, 6.2 formulas. If it would help you just to take a picture of it. Those are the ones that you're going to need to know on your own.
What is the semi-perimeter?
Semi-perimeter. You just add up all the sides, divide by 2, and that's the number that goes in all those places in the square root. I don't know exactly what the letter is who's missing in this, you know what I mean? But whoever this guy is, that guy is, and these are the other guys. So like technically it'd be B, B, A, C, A, C. See what I mean? So it's kind of understanding who's who, and then you kind of know all of them.
Okay.
Yeah, but I don't know exactly the letter on that, so I just gave you one.
You were trying to stay with tangents when you really wanted to get to secants. So my advice was, hey, this could have been a secant square because you're trying to get this one. And then
Like when you project. Yeah.
this would be secant square. Okay, plus 1. Oh yeah, you would have had it. Because then secant squared is 1 minus negative 1 would be 1 plus 1 equals 2. Secant squared would come in, distribute, so it would be 2 secant squared
So like this. Like how far?
plus secant to the 4th plus 1, which actively makes
Yeah, it does.
1.
So
Oh, the negatives in there.
pretty good. Alright. That's 6-5.
Touchy.
Alright.
You know how to do it. No cheat. Programs. Count on the big brain. You think you're not a smart guy?
Alright guys, if you need some chocolate inspiration, there are SpongeBob brownies up here at the front for sale. They are quite amazing, they're just $1. Otherwise, I will see you guys later. Come by, drop by at any point today if you need it. I can write you 7th period passes if you want to come in during your PE classes. Sorry, nothing else. Okay, you got it another time. Otherwise, after school or tomorrow, if you want to drop by and show me your rep or your formula card, so you can push it. I can also give you some pointers if there's something that you've left off or you've written down and corrected.
John, why'd you send me all that random?
Why don't you hold the door for security?
You're welcome.
Misty. Yeah.